Alright, hello, welcome. So today we're gonna continue learning some physics, and the topic today is momentum. So we're now going to begin discussing momentum. So what do we understand usually when someone says the word momentum, or when we hear the word momentum, someone says it or we see it in a sentence? What do we understand? So sometimes I guess a basic understanding of momentum is that it could be understood as the quantity of motion that an object has. So the quantity of motion that an object has, right? Now, the quantity of motion that an object has, we can extract that from this mass and velocity has a big impact on momentum. But before we could understand momentum, we need to know what mass is. So, isn't mass the amount of matter that something has? And velocity, we know velocity as the distance something will cover over the time taken to cover that in a particular direction. And therefore we could think of momentum as motion, but not just motion, but mass in motion. So we don't just have mass and we don't just have motion. We don't just have mass and we don't just have motion, but we have mass in motion. Two types. The first type is angular momentum. Angular momentum, as we can see, is the momentum of an object that is either rotating or in a circular direction, right? And the second type of momentum is linear momentum. And the linear momentum of a body is its mass multiplied by its velocity. Now, luckily for you or anyone doing CSEC, angular momentum is not really necessary for you all to learn. However, it's very, very important that you do learn linear momentum. Alright, so when we talk about momentum, we have to realize something. We did mention velocity. We did not mention speed. And we know that velocity is a vector quantity. So what does that mean? If velocity is a vector quantity and momentum is velocity is used to get momentum, then therefore momentum has to be a vector quantity as well. So the symbol for momentum is P, common P, not capital P, right? Because what is capital P? Capital P is pressure. So we know that the symbol for momentum is common P, and we know that momentum is equal to its mass multiplied by its velocity. So we know that momentum will be the mass of something multiplied by its velocity. We know though that the mass of something is measured in kilograms and the velocity of something is in meters per second, and therefore momentum, the units for momentum, will be kilogram meters per second. Example A. A car of mass 900 kilograms is driving at 20 meters per second. What is its momentum? So first we have to write our formula. So we know that momentum P is equal to the mass multiplied by the velocity. What is the mass of the car? The mass of the car is 900 kilograms multiplied by the velocity of the car, which is 20 meters per second. 9 twos are 18,000 kilogram meters per second, and this is the momentum of that car. So part B. The same car traveled some distance and its momentum became 14,000 kilogram meters per second. What was its velocity? So the first thing we want to do is write the formula. Momentum is equal to the mass by the velocity, and therefore what do we have? That's what we have to ask ourselves. So we know that the momentum is 14,000 kilogram meters per second. We know that the mass of the car wouldn't change, so it remains at 900 kilograms, and that multiplies by the velocity that we don't know. So therefore the velocity will be 14,000. Oh, sorry. I would just like to change this to 14,400 to make it easier to solve. Right? So 14,400 over 900. Zeros will cancel, and 9 into 144 is 16 meters per second. Okay, so these are some examples of the most basic questions that you will get on the topic of momentum. Alright, the next video will be explaining how Newton's second law is related to momentum, and then after that we will go into understanding the law of conservation of linear momentum. Thanks for your time. I hope you learned a lot, and I'll see you in the next video.